In theory, 2 moles of nitrogen 14(7) can undergo fusion to produce 1 mole of Si2814 plus some energy. What would be the mass defect of such reaction? Now, what is a mass defect? Mass defect, that is delta M, is equal to the mass of reactants minus the mass of products. Now, what is the reaction over here? It is nitrogen 14(7) plus nitrogen 14(7) is giving out Si2814. So what is the mass of reactants will be? Is equal to 2 into 14.00307, and that will come out to be 2 into 14.00307. It is 28.00614. Right? Now, the mass of the product is, it is 1 mole. So the mass of the isotopic or mass of product is equal to 27.97639. Right? Now what you need to find out? It is the mass defect. So delta M will be equal to 28.00614 minus 27.97639, and this will give you minus 27.97639, and that is equal to 0.02975. Right? So this will be the mass defect over here. So what will be the answer to the first question? It would be 0.02975 AMU. Now, what is our second question? Calculate the amount of energy produced in the given reaction. So, your energy is equal to, what is the energy equal to, students? Energy, that is the B part, is equal to delta M into 931 mega electron volts. And now this energy is 0.02915 multiplied by 931, and that is 27.1386. Now, this is how much? This is mega electron volts. So what is the energy produced in the reaction? It is 27.1386. So this is the way how to find out the mass defect and the energies. Now let's take up a few more questions. Like, now let's take up one matrix match type question. Right? Say, I'll write one matrix match. That is, you have to match column 1 and column 2. Now in column 1, we have xenon 218 96 2, or I can take it as X. X218 96 to Y206 92. Second option we have got X214 94 to Y206 90, then X194 88 to Y194 90, and X197 91 and Y196 92. Here you have got alpha particle, the beta particle, positron and gamma rays. Now, what is this? How will you match it, students? Say 218 to 206. What all are the particles emitted? Yeah, what all other particles will be emitted? How many alpha and how many beta particles? In this case, is it that only alpha particle is emitted? 218 to 206. There will be few alpha particles, that is 218 minus 206, and it will give us what? It will give us 12. So how many alpha particles are emitted? 12 divided by 4, and these are 3 alpha particles. Is there beta emission also? We can take out the number of beta particles. That is 92 minus 90 by 1, and that is equal to 2 beta particles. So in the first case we have got both. Say I am marking it as A, B, C, D. In the first case, what all are the emissions? A and B. Now in the second case, what is the thing? Sorry, what all are the emissions in the second case, students? (214 to 206). Again, there will be alpha, beta, and here, isn't it in the first case gamma particles will also be produced? There will be few gamma emissions also. In the second case also there will be alpha, beta and gamma. That is the D option. Right? Now in this case we have got what? The third case. 194, the mass numbers are the same. That is, X is in the third case, that is your X194 88 to Y194 88. What is happening? The mass numbers are same. What has happened to the atomic number? Atomic number has increased from 88 to 90. That means what emission has taken place? Just tell me. Is there any emission where atomic numbers will be increased by 2? Can I make it like there is 1 alpha emission followed by 2 beta emissions? Say after 1 alpha emission, what will happen? The mass will be decreased by 4 and the number will be decreased by 2. After 2 beta emissions, mass will remain the same. and the number will be increased by 2. So what is the right option over here? In the third case, it will be 1 alpha and 2 beta. Right? Okay. Now can I say that there is a positron emission? If I take out the neutron-proton ratio, that is 194 minus 88, I'll get 106 divided by 88. The ratio is 1.2. Can it emit a positron? No. The ratio is more, so it has to emit a beta particle. Now in the third case, students, what is happening? The mass here also remains the same. The mass is remaining the same, and listen, gamma particle will be released in each and every thing. Now here what is happening? The atomic number is increased by 1. So what type of emission will be there? There will be the positron and the gamma particles. Right? So this is the way we can find out the emissions. We can calculate the mass defect and the binding energies. Right? Say, one more type of question can come from this topic. I just wanted to discuss one more. That stable nuclide can be obtained for Z is equal to 43, N is equal to 35. Likewise, Z is equal to 61, N is equal to 89. This is the first option, the second option, the third option, that is A is equal to 8 or 5, or D, A is greater than 209. So stable nuclides cannot be obtained for, sorry students, the question is cannot be. So how can you find out? What is this N over here? N35, N89. So 43 is the atomic number. And what is N? N is, I don't think so, N has the number of neutrons, or we can say the mass numbers. I think I should change this question a bit. This is the Z, and if I am making this A equal to, so if I am making this 88 and this thing, that is your A will be equal to, if I am making this 126, can I obtain a stable nuclide? Z is the atomic number. Now in this case, the number of neutrons will be equal to how much? It will be 45. Is this the magic number of neutrons? No. So a stable nuclide will not be formed. Whereas in this case, if I am making Z is equal to 61 and A is equal to how much? 126 minus 61, it will give you 65. Are these the magic number of neutrons and protons? No. So we cannot get the stable nuclide from either of them. Right? So in order to find out the stability, what you need to find out is the number of neutrons and protons.